Light travels at 300 million meters per second, enough to get to the moon and back in less than a second. Let's look at what it's made of. So we should remember from primary school that the 7 colours of the rainbow, if you mix them together, make white light. Now, there are 3 primary colours which are different to paint. Be careful with this. They are made of red, blue, and not yellow, but green. So out of these 3 colours, you can make every other colour. Now, let's look at the secondary colours we might have. Now, blue and green together make something called cyan, a light blue. Red and blue together make magenta, and red and green will make yellow. Now, out of these different primary colours, the red, blue and green you can use in basically stage lights and printing press to make every other single colour, not just those secondary ones. But it's worth noting here, if there was no colour at all, it's black, and if it was all colour, like we mentioned earlier, they make white. So let's look at a few different situations there, like what is colour? Now, when light, we're going to talk about white light, reflects off a surface, and we're not talking about mirrors necessarily. This would be an example of diffuse reflection, so from a rough surface. Now, the way we talk about reflection from a smooth surface would be specular reflection. So specular reflection, like a mirror, but a rough surface like a table or trousers or carpet would be diffuse reflection, where you can't see a face in it. So let's say for white light going in, we have red light being reflected. So how would we know or like what the surface is? Well, we look at what's reflected. It's red light that's reflected. Where's all the other colour gone? Well, if it doesn't come out, it means it must be absorbed into the surface. So for this question, red light is reflected, all other colours are absorbed. So the surface must then appear to be red, and that's what colour is. It's just what your eyes view objects as being depending on what they reflect. Let's say it was red and blue that were reflected. Now red and blue together, we just looked at, makes magenta. So if it was red and blue, then it would be magenta that was detected by your eyes. And this time it would be all the green light had been absorbed. Let's look at what would happen if instead of reflection we talked about different colour filters. So let's have some white light again. This time it goes through a green filter. So through a green filter, you've probably had a look at these at school. The white light that goes through, only green will be transmitted. Transmitted means it goes through an object. All the other colours, same as before, are absorbed. They do not get through the filter. So that's why we see those objects as green. Next, let's have the green light. Let's try and put it through a red filter. Now, in the red filter, does red emit green light, transmit green light? No, it does not. So therefore, green goes in, red only lets red through. It does not emit or transmit any colours. It absorbs everything. So no light would go through, so you'd actually like see black if you were to look through the end of that filter. Now, what about if it was an object instead of a filter? So imagine you had a red filter over your eye, you looked at a green tree. Because there's no red light in that green, that object would appear to you to be black, because there's no light getting through the filter. Black meaning no colour at all. Now, this can work with all colours, but it's easier to talk about in terms of primary colours because those are the most straightforward ones. A couple of key definitions to do with light to finish off is that transparent materials means all light is transmitted or let through. Translucent materials means some of the light is transmitted. And opaque materials mean that no light at all is transmitted. It's all absorbed.